Good morning, everybody. My name is Jacques. I am the founder of the Singular Numerical Relativity. Today, I would like to explain about one very important aspect of mathematics that we don't know yet. And this is about the mathematics of numbers. When I say mathematics of numbers, I mean really mathematics based on the studies of numbers. So we are going to study the mechanics of numbers or the physics of numbers. Why? Because we don't know so much about numbers, what numbers are in reality. And here you are going to find out that numbers are more than what we think. However, I will not really go into details right now. We will focus on one point, what makes these studies possible. The studies of mechanics of numbers are made possible by the nature of relativity that is found in numbers. So, numbers are relative or flexible. When I say relative and flexible, I'm referring to exactly the relativity of Einstein. The same relativity that Einstein explained 100 years ago is what I'm going to explain based on numbers. As introduction today, we will talk about the illusion of numbers. Einstein talked about the illusion of time because we have a certain way of understanding time. But Einstein came to prove us that our understanding of time was not right. Therefore, he was able to explain that time was relative. The illusion I'm talking about here when it comes to numbers is about the value of a number. I say the value of a number is relative. For you to understand this idea, I like to show you these three bills of US dollar. These three bills, basically, they have the same value because it's the dollar. However, there is a difference between them. We give them different value from one to another. This is a bill of $1. This one, $20. And the other one is $100. So what makes the difference between them is the number. Why? Because if I will ask you to choose what bill you like to have here among the three, for sure, 100%, everyone will go for this $100 bill. Why? Because we believe that we have much more money than $20 or $1. Why do we give more importance to the $100 bill? Because we have a perception of numbers, but we don't mind about. We see numbers as a compilation of many units. A compilation of several units called 1. So if you have a number like 100, you have more units of 1. Look at the way we see. When you see, for example, the $100 bill, you see it this way. Not just as one block or one note. You see it as a package of $1 bills and 100 notes of $1 bill. You see it this way. So you can count 1, 2, 3, 4, 5, 6, 7, 99, 100. So if you see 100, you see it as really a lineup of units of 1. That's why 100 is different from 20. And what makes the difference is that this way, because we see the compilation. So the value of a number will depend on the number of units of 1. So that was the value. Then we say in general that the value of a number depends on all the numbers below it. Because when you see 20, 20 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. 100 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 100. You understand? This is the real way we see numbers. So we see numbers as units, not as blocks. Then, because of that, numbers have power. What is the power of a number? A number can be in many places at the same time. A number can fulfill many tasks at once. I would like to tell you that, as we said, the number, for example, 20 is not just 20. 20 means 1, 2, 3, 4, 5, 6, 19, 20. So all these numbers below 20 are part of 20. That's why 20 has the power to use any of these numbers below it. We call them values at the same time. Any value below it can be used by 20 in order to fulfill a task. For 100, we do the same. As a matter of fact, if you have $100, you go to a store, then we'll buy a gift for someone for $12. You will be given a change. The change will be given to you as $50 bill, $20 bill, $10 bill, $5 bill, $2 bill, and $1 bill. So you have all these bills. All those bills come from the 100 bill here. So out of 100, we can produce bills of different values. We can produce bills of 99, 87, 52, 50, and etc. Down to 1. So we have more degrees of freedom. For 100, we can do more. So that's why, if we go back to our example here, after buying your gift, you have all these bills. You can still buy other items out of these bills. So you can assign 50 to buy, for example, a radio. You can assign 20 to buy a blouse. You can assign 10 to buy shoes. 5 to buy sardines. 2, you buy maybe candies. And 1, you can assign it to buy something else that costs $1. So in that case, everything that 50, 20, 10, 5, 2, and 1 will do will be done in the name of 100. All the tasks that will be accomplished through these bills are the tasks of 100. Therefore, 100 can be in many places at the same time, because if now you send people, you go there, so it mean you assign them in different locations. They can be in different locations. These bills, the other one goes to the grocery, another bill goes to the shoe store, another one will go to. So all of that at once can operate. And if you break down again the 50, for example, you can use 30 for this and the 20 others for another thing. You can divide it as you wish. So this gives us what we call the degrees of freedom. So the bigger the number is, the more degrees of freedom we have from that number. The more tasks we can accomplish with the number. So because of this, numbers have a structure. We used to think that when we have number like 7, we see number 7 as just a block like this. But here we say that numbers are like antenna. This antenna, you see this antenna, this is antenna. At first, it's just something small, you see it. But inside this segment are other segments, and when I pull, you see what happened when I pull out. All the segments come out one after another. So this shows that the number is like this. Inside 7, I have other segments of 6, 5, 4, 3, 2, 1. They are inside, but you can't see them. But in our mind, it is there. It is inscribed in our mind. That's why we are talking about illusion. In our mind, it exists, but we don't notice it. And the fact is that when you have this number 7, if you pull, all these values will come out. And 7 can use each of these values to fulfill anything it wants to fulfill. It means if you have $7, you can buy anything that costs $6, $5, $4, $3, $2, $1. You can assign any. So these are the degrees of freedom given to us, given by the numbers. And numbers, they have what we call the levels of variability. So all of these are the levels of variability of number 7. And speaking of the levels of variability, we see that if you have a number like 7, this number vibrates. This is the same thing we have seen through the antenna. If you look at the antenna this way, so when you are opening, you see that you are getting into small, there are big circles and going, so these are the levels of variability. And because of that, a number looks like a spring. You see the spring, the spiral spring, which on one side is very small and on the other side widely open. So if you go, you see that gradually they are arranged from the smaller one to the bigger. While going out, you are getting bigger and bigger. And this is what you see. So now, if you want to know the number of levels of variability for any number, you just get that number plus 1. For 7 here, it's 7 plus 1. So it means number 7 has 8 levels of variability. Number 10 has 11 levels of variability. These are things I'm going to explain when we are going to study the physics of numbers proper. So, speaking of physics of numbers, what makes this physics possible? Because as we have seen, the structure of a number is like this antenna. So it means it can go forward and backward. And when we go like this, meaning we stretch it, and we can again pull it down. Because of that, because of this movement, numbers produce energy. And that energy, we can calculate it. Therefore, we are going to study the acceleration of a number, the deceleration of a number, the expansion of a number, the projection of a number, and the explosion of a number. When I say acceleration of a number, this can be fulfilled in 1 dimension, 2 dimensions, or 3 dimensions. All these operations can be fulfilled that way. That's why, as we are going to study the physics of numbers, we will be going through the details to show you how to calculate the acceleration of a number, how to calculate the deceleration of a number, the expansion of a number, the projection of a number, and the explosion of a number. These terms exist in the real world. They exist, but nobody thought that they can be applied to numbers, and this is a new idea. So all you have to do is to follow my next explanations about all of this, then you will understand how all these operations work and what they will do for humanity. Now, if we want to know exactly why we are studying all these mechanics of numbers, it's simply because there are problems that exist in science. Science is still growing. Science is still a zoo of discoveries. And one of them is this one we are discovering now together. So what is it for? It is, we are going to study relativity based on numbers, because we have to complete our understanding of Einstein's relativity, because the general relativity still have a problem. It cannot explain the world at small scale. That's why Einstein left it there, and someone must complete. Therefore, this is the time to complete it. Next, we have also many problems in physics to solve. The problems are, some of them I mentioned here, not all are mentioned here. Some of them are this, like the unification of general relativity and quantum mechanics. So far, it's a big question, how to unify them. Another problem is quantum gravity. Nobody knows how gravity works at the fundamental level. So far, quantum mechanics has been used to try to explain that, but it failed. Many theories came to try, but they failed. And I would like to tell you that this time, here is the solution. Also, we will resolve the problem of uncertainty principle, because this uncertainty principle is a problem. No one knows how to tell the outcome of a physical reaction or a chemical reaction. When two particles collide, what will be the outcome? Nobody can predict. And that's a very big problem in physics. So we have to resolve that problem. Numbers will tell us clearly what to do. Then also we will be talking about the black holes, the Big Bang, and the singularity. These are very important, and the whole theory here is called the singular numerical relativity. Why? Because we are going to reveal what singularity means exactly. Also, we will be giving you a new way of understanding information. This is a theory of information 100%. That's why we will only use numbers. We don't involve any equations that you know already before. We don't need them here. Here we will use only numbers in order to explain everything. And that's why this is a theory of information. And as a theory of information, it's going to revolutionize the information technology, because this is going to introduce us to the entanglement of quantum bits. How to have computers that can work with quantum bits. many quantum bits at the same time. That's why we are talking about numbers. Our basic idea today, we are telling that a number can offer all the possibilities, because a number can multitask. A number can be in many places at the same time, and that's the property of particles too. Particles work that way. But the reason we were not able to solve the problem, because we did not know that numbers are part of physics. Now we are introducing numbers as a new tool for physics. So please follow my explanations in the next lectures I will be giving. Next time I will start already explaining about the physics of numbers, acceleration, deceleration, explosion, etc. I will explain all of those. Do not miss, because it's very important. You miss these, you don't understand, ask questions. Please do not judge by simply saying, oh, this is man-made. No, this is not man-made. It's a reality that you don't know. You always think that 7 is 7. No, 7 means 1, 2, 3, 4, 5, 6, 7. That's 7. Understand? And it gives us all the degrees of freedom that 7 can provide. So be with me in the next lectures. Thank you very much.